question number 9. So the question reads, what is the remainder when 3x to the power of 4 plus 2x cubed minus x squared plus 2x minus 19 divided by x plus 2? So this is what we call long division. I covered previously there's a technique called synthetic division. I probably will cover that too here. But basically, the remainder of this quotient helps to signify that the divisor itself is not a factor of the division, right? So long division is basically a way to check whether or not that the divisor is a possible factor of this polynomial. When you get to larger polynomials, so anything greater than 4, 5, or 6, when you get up to those numbers, it's really hard to factor them manually. So you can use a different technique by guessing or extrapolating the factor and then using long division to figure out whether or not it is a factor. It is indeed a factor. Okay. So here it's telling us that there is a remainder, right? So usually in normal division, whenever you have a remainder, it's a fraction, right? It's the remainder over the divisor itself, right? In this case, it is the same thing. So we're going to find the remainder for this long division through long division, okay? So first of all, I'm going to draw a big divisional bracket here. We're going to put in our polynomial, okay? Okay, and then we're going to put our divisor here, or the possible factor. Okay, so basically how to divide is by treating these as the digits of a number and trying to simplify them as we go. So we see here that we have a 2-digit number or a 2-term factor here. So we're going to try to get rid of 2 digits at a time here. Okay, that's how you kind of think about it. It's easier to just do the example. So how do we get rid of 3x to the power of 4? So we can multiply our factor by 3x cubed. Okay, so let's multiply it by 3x cubed. So if we multiply this by 3x cubed, we're going to get 3x to the power of 4 plus 6x cubed. Okay, all right, so as always, we subtract these, and we got rid of our first big digits, right? So this is equal to 0, and this is equal to negative 4x cubed. All right, we're going to move down our next digit, or our next term here, as negative x squared. So how do we get rid of negative 4x cubed? We can multiply it by negative 4x squared. Okay, so we multiply this by negative 4x squared, we get negative 4x cubed. Oh, that's a 2. Minus 8x squared. If we subtract this, negative is positive, so this equals to 0, and this equals to 7x squared. Just want to make sure I'm not messing anything up here. All right, next, we move down our next term. All right, plus 2x. So how do we get rid of this? We can multiply it by 7x. All right, so if we do that, we get 7x squared plus 14x. Subtract, we get, oh, that line was bad. We get negative 12x minus 19. We're almost there. So how do we get rid of the negative 12x? We can multiply it by negative 12 itself. You get negative 12x minus 24. If we subtract these together, we get 5. So our remainder here is basically 5. So remainder equals 5. All right, so this is one way you can do it. The other way is through synthetic division, and I'll go through that now. So the way synthetic division works is you take the coefficients of your polynomial, of your dividend, and you'll take the solution to this factor. So in this case, x plus 2, so the 0 for this is negative 2, or the solution is negative 2. So we're going to take the solution, we're going to write it out like here. And we're going to have an upside down division bracket, okay? And we're going to write the coefficients of our polynomial, which is 3, 2, -1, 2, and -19, okay? And what we're going to do here is we're going to take our first coefficient, move it down, and multiply -2 by it, and add it to our second one, and move that one down, okay? So if we move it down here, we get 3, and we're going to multiply this to -2 times 3, and we're going to add it to this, okay? So we're going to add -6 to 2, and we're going to get 4, all right? So I'm just going to illustrate it once, and then I'm going to do the rest because it's going to get messy. So we multiply this, which equals -6, and then we're going to move it up here, and we're going to add it to this, all right? So we're going to add -4 to this, okay? So if we do that, we get -2. Sorry, we subtract them together. -2, -6. So we get, why am I saying 4 here? This should be -6. Sorry about that. This should be -6. So that if we do the addition for this, we get -4. -4 times -2 is 8. 8 plus -1 is 7. 7 times -2 is -14. Plus 2 is -12. Okay. And then finally, we get -12 times -2, which is 24. 24 plus -19 is 5. Okay, so how do we read this now? So the last digit that we get is going to be our remainder. So if this digit is equal to 0, then we know that this is a solution, or this is a 0 to our polynomial. But if we have a remainder here, then this is in fact not a solution. Okay, so this is our remainder. So we'll just box this off and label it to be equal to r. And these coefficients here are the coefficients of the resultant dividend, or the quotient, sorry. And the quotient has 1 degree less for the polynomial. So the quotient is, in fact, so this is going to, if this is x cubed here, then this first place, this first digit here is going to be x squared, and so on and so forth. So this is x squared, this is going to be x, this is x, this is going to be the coefficient c, and so on and so forth. So this is x to the power 4, x cubed, x squared, and x, and this is c. Then this is going to be x cubed, x squared, x, and the coefficient itself. Okay, so that's how you read it. And if I did it all correctly, then these two should be the same, because these are just two different methods of finding the same answer. Okay, so the remainder is 5, and we did this through long division and synthetic division. So the solution is correct. All right, finally, let's move on to the last question of the day.